All right, so good day, learners. So today we will now jump to our next video tutorial. So we finished already on data visualization as essentials, telling stories with graph and figures. So basically, last time we had produced a box plot, histogram, scatter plot, bar chart, and then to be able to look at the patterns of our data. So today we will try to jump on the t-test for beginners, comparing two groups with confidence. So basically, what we are doing now is we will now apply the inferential statistics or just looking at other statistical differences. So now we see that we our group of variables is there is a variation by looking at the box plot, the histogram, and also the relationship between the scatter plot. But then we don't really know like if it's there is a significant among the groups. So one of the most and basic statistics that we can apply is the t-test. So in this t-test is usually we need to at least to have two groups to be able to see the differences among the groups. So now let's try to jump directly to R. So this is already like a pre-made code, but to make it more useful and not to, not to mess with our code. So I'm gonna try to make a new R script just to have an overview to our learners today. So let's try to uh, upload or load so basically, I usually do that. So let's say load library. So in case I'm gonna load library tidyverse, you can see there the library is being loaded, and we are ready for a SQL analysis. So in this case, let's create a simple database, data set. I would say I can use my own database a lot. So and I think it's better to work first on a small data set, and after that, you can run the code with your large data. So in this case, I'm just trying to look at differences of DBH among two core sites. So again, for t-test, you need at least two groups. So you wanted to compare, let's say, for example, for the scores of your students. So let's say you have two classes and you give them a lecture, and after that you give the quiz to them, and then in the end the first group was they did not get a lot of score, but the other one did get a lot of scores. So it's like what happened because the way you delivered the lecture were the same. So you can have asked the question like why? Like was there a problem with my lecture on the first group, or was there a problem with the second group where the first group got the high score? So that's that's then you can apply that to test like there's inner differences in terms of the scoring or how you did your lecture. So in that case, let's just try to work on this for the sides, okay? So now let's try to create a simple data set. So in creating a data set is you just sit seed 1, 2, 3. So side A, I will say side A. So let's say uh and side B. So we have 30. I mean, so this is 30 variables. Mean 25, standard deviation 5, and so you can see the mean for side A is 25, but the side B is the mean is 30. So we can expect that side B is more higher and the standard deviation. But this is just like imaginary data set. So data table, side A, read B, and each 30, so side A, and then in that case, now we have the data. So 60 observations. It's in 30 plus 30, that is 60 here. And then you look at the DBH. So here, DBH, A, but we already know the data that our site B is in term by looking at the 30 dBH, it means that this is, I'll recommend this side is bigger based on mean dBH. So let's just put it that way, just to make us a little bit of idea that what's with our data. So let's try to look at the overview of our data. So here now, previously we work on 6 observations. Now we are now on 60 observations. So our data set is increasing. So, but maybe I will try to make it to more 60 to make it more a lot. So let's try this one if it will work to make this data set exciting. So unfortunately, it's not working like that, but here it should be six. No, 13 should be 16. Yeah. Okay. That's weird. Should be 60. So side A, B, H is 60. 101 is 60. And side. No, out of this verse 60 observation. So let me just double rerun this code again. Standard deviation 5. Now we have this 60, 60. Now let's make it. So now we have 120 observations. So yeah, it happens like that. So make sure that you rerun or you clean your environment because sometimes ours, but it's confused about what we're doing here. Anyway, so let's try to look at the head. So here it's a lot, and let's just try to make it dimension. So dimension of our data. And I want to look at summary of our. So basically we only have 2 variables. So 2 variables, DBH and the site. So let's try to look at that. So see, you can see because we only have 1 variable. So you have the site, 120 character, and the DBH, you have DBH, which is 14 minimum. The first quarter is 24, median is 28, mean is 27, and quarter is 30, maximum is 44. So which is it's a lot, I would say. Um, that's interesting data set that are is created for us. So anyway, let's just run this code to look at the pattern. So in that case, I'm gonna visualize this data. So I don't want you to look at that, but I want you to like let's do it like step by step. So when you do the ggplot, you just say ggplot data, that's aesthetics and the site because you wanted to doing a box plot. So because you wanted to look at the pattern between 2 groups, which is sites. Our groups here is sites, and we want to look at AVH. So remember that. So I can write a comment here. So 2 sites, A and B. So basically, we just wanted to look at the differences. Um, the differences. Let me just delete this one because I don't want that like that. So now I will just copy it on Geom box plot. So this is what we want, right? So fill sky blue. So I'm gonna just copy it just for you to understand it properly. So you can change it to maybe like I don't know, like just block. So let's change it to block. I think block is better than so now I'm gonna include the title. So labs the title, which is the one you see on the top. So labs here, I'm gonna put deviation comparison between 2 sides, and I'm gonna put it X axis, which is site, and Y, which is DBH uh below uh on the Y axis. All right, so let's run this code and we will see. That's interesting here to see. If you already see that site B is at higher DBH and site B is lower. So we already detected that because I have mentioned that we are the one who created it set and site B, the mean is 30. It means that we already know that our data set, site B is at higher DPH. So this is how we uh, visualize our data set, and then you see, oh, okay, that's interesting. So we can say like okay, I don't like the black one. I like the maybe blue because it's more, I would say, professional. So I would say, okay, site. Now you have E and B, and you have image comparison, two sides, and I'm gonna save it as PNG, and I will change it to DBH comparison between two sides, and then I just click save, and I will check in our working folder. So then you have it there, DBH comparison, two sides. But then because I'm gonna write like a feature caption, so I will try to remove the title. So I can remove this title like this, remove the title, and let make it empty, and then there you go. There's no title there because I don't want to make my figure messy. So new box plot. So let's say new box plot. Let's say no title. And there you get it. I will try to no title. It says here. Then you see there is no title on the top. And then there's a time kind of I will write it here. And then I will start the figure box plot pairing two sides. So side A is separately disturbed. Let's just put it this way. And side B is less disturbed. So in that case, we can say, oh yeah, because side A is less dBA, so we can strike that because of the disturbance. Side A had lower dBA, so we expected that all the trees were damaged, and the B had higher dBH, meaning to say that side B is less disturbed compared to the other side. Okay, so let's continue. I think we cannot already know the pattern of with our data. So let's try to check the normality. So what is a check normality? So because we already know that there are differences among the two sides, but we cannot really sure like what is your scientific basis to tell to your readers that indeed there is differences among two groups. But by looking at the backspot, we can already say that there is really variation. So let's check the normality of our data. So check normality. So of course, I'm gonna digiplot data DBH because we wanted to look at our DBH and geom plus geom histogram means 10. So I can run that and see this is our histogram. And then we can say, oh, that looks really good. It looks like a normally distributed to me. So in that case, I would assume that our data is normally distributed. So if you think that there will be a lot of values on the left, on the right, then it is not normally distributed. Okay, so for the for the normality checking, we can use Shapiro-Wilk test. So just it's very simple in R. At first I was like, how do you check normality? Then I realized that it's just very simple in R. So you just do Shapiro test and the data, and you use the DBH, and there you go. You can see the results below. So here is our results. So remember what we are interested here is just looking at the p-value. That's all you wanted to see. Our p-value is 0.02. It means that the p-value is uh it means that it's not significant, which means but the p-value is greater than 0.05. So that means that our data set TBH is normally distributed. We can also already see that in our histogram. So now with that we can proceed to our so-called independent t-test. So what do you mean by independent t-test? So there is the so-called independent t-test and paired t-test. So what's actually the difference? What's the difference between the two? So independent t-test is you are just trying to look at the differences among two groups without any relevance. So let's say group one, severely, side A, severely disturbed, and side B, less disturbed, but there's no relevance. You know, side A, maybe it's in, I don't know, somewhere in Manila, or I don't know, it's side B somewhere. So like there is no relevant, the data is independent from each other. But for the pair t-test, it means there is like some kind of two groups, but they are somehow related. Say, let's say, for example, you wanted to look at the score of your students, like before you deliver the lecture. So you had a like a, I don't know, random quiz, you give in the quiz for your, but you didn't get the lecture, you didn't give the lecture first. So and then you found out that they don't really understand at all because you didn't discuss it at all. So you didn't expect them to get a high score, but then after you deliver the lecture they get like almost perfect. So it means that when you look at pattern, the pre and the after lecture, it means that there is like, you know, when you give the lectures, the student will somehow understand what you are trying, wanting to learn. So that's like a peer teacher. So for example, another example for in inventory. So basically, basically, what what you can example is that let's say you water the plants today, or yeah, let's just put it make simple. So you put the fertilizer this week, and you try to have the database before putting the fertilizer, and then you measure the DPH again after the fertilizer. This is like something out of a peer t-test. So let's now run the independent t-test. So this is just the t-test. So peer t-test, I can just, you know, write this t-test. It's simple. And then I'm gonna do that the t-test, and then so first I would write the numeric. So always write the numeric, then the non-numeric. So here VBH, and you use the sign and the site, and then what kind of data you want to use. So data is called data, but in this case it's data. So if the name of data here is, let's say, I don't know, new data site, so you can put here site, but here data should correspond to this data. And the variance, let's see, the variance equal is true. And let's try to run this t-test. All right, so now your t-test, but here is the t-test, and I'm gonna do this, run it. So t-test result, because we changed it. So I will just run this, remove this one here. So our t-test is this one. So just look at here, there's two sample t-tests. So what you need is just looking at this p-value. So our p-value is 0.00015. So see, looking at the p-value is, we can already say that there is a significant differences among the two groups. All right, so now let's um work on the peer t-test. So peer t-test, again, I think I discussed that already, but we cannot use our data because these are independent data, side A and side B. So let's just create another data set for the peer data. So this is like before, let's say score. I would say score. Just make sure. So let's say before lecture, after lecture score. So you have the 20, the mean, and the standard deviation. So you can see that this, I want to change this one. So let's see, because the before is 20 and the mean after is 20. So let's just so swap this. So let's see, this is 2 and this is 20. So we already I would expect that before lecture the score is 2, the mean is 2. It means that there will be low scores. But after, it means that the mean is 20, which is higher than the 4. So let's just try this one. Before is because I have to make sure that this is right here. Okay, I'm gonna run it again, and now there you got it. And to do the peer t-test, just table before and after. So peer data. Okay, peer data. So because I changed it, that's why you have to be careful with this our naming. So here before, we should use it before. You should include before, and after you should also include after. Okay, so gonna run that. Now you got our peer data. So see, before score, after score. So see, we can already see that 4, 19, 1, 22. So by looking at the individual data set, you can already see, oh, okay, that is interesting. Yeah, but you already know what's gonna happen. So now for the t-test, so paired data before and paired data after and paired and true, and you run it. And there you go. So let's see what we got there. So unfortunately, but it's there's a lot of uh before not found. That's interesting to me. But let's just say before score, after score. So before score, after score. Aha. So because yeah, should have used the actual. So because I have to make it sure that it should be scored. Okay. And then I run it, and there you go. It's not perfect. So this appear t-test. So you don't have to look at other things stuff there. Just look at it right away at the p-value. The p-value is less than 0.222 something. It means that it's highly uh significant. So it's less than 0.05 because we already know the fact that look at that before it's 0.4, 19, 122. So it's like a really huge difference. But we can also try to just to look at the Hest their data. Hmm? Let's just try to look at that. Their data and let's say before score. See, that's very uh, it's not normally distributed, but you can see the score is between 0 to 4, and then we can try to look at their, their score. So see, the score is more onto the left, which is 16, 20 to 24, and maybe we can use our uh, box plot here. Just utilize it. They have, that's a good thing in R. So let's say I'm gonna just copy that, and then I'm gonna know what are my variable. So data names data. No, this is pair data. So pair data. So before score and after score. So let's say I will try to look at um summary. I prefer the summary because it's our numeric. So paired data. So now we can see the paired data. It's very simple analysis. Summary, you have before score, after score. So you can see the minimum, it's a negative, minimum 13. So see the differences. Median 21, mean 1.5, mean is 21, third quarter 22, and maximum is 25 for after score, which is basically it's understandable that we expected the after lecture score is would be higher. Okay, so let's try to this is run this again. Our last code. So the effect. So let's try to load this library. So library effect size. Now it's loaded. Data we have here. Yeah, you're right. So coherence, the division side, effect size, and let's just run this at effect size. So this is interesting here. And this is what it says. Basically using full coherence negative 71, 94 till 95 confidence interval is negative 2.3. So the next is how do you interpret this actually? How do you interpret the results of your I can just run this one like this, and I have here So how to write results thesis paper. So element t-test. The mean DBH inside B is 30, was significantly higher than inside C based on our t-test, right? You know that. We showed it already. T34 p-value, which is 0.001, and Cohen's D85, indicating a large effect size. I mean, you already see the differences. And for the beer t-test after treatment, so I want to say after lecture, because I changed the story. After lecture, she showed a significant, let's say, I would say, scores. Showed a significant increase after lecture. All right. So this is how the story you just wrote. And now you're ready to write your paper. Like there's no significant effect, and before and after, and the p-value, which is point something like that. So this is how it works. And what you do is you can make a table out of it, and you just indicate the p-value, the one that we use, like it's a p, the significant or not. So I think that's all for today. And this is the t-test for beginners comparing two groups with confidence. So again, I want you to understand the difference between independent and peer t-test and assumptions, whether the data is normally distributed, and visualizing group differences and how to write results properly in your paper or in your thesis. So again, this is my contact. You can reach me out at my email, rodrigorafi@gmail.com, or my work email, rafi.rigo@ipso.edu.ps. So I'm looking forward for our next these trials. In that case, I will be working on uh, ANOVA made simple, testing differences across multiples. This is really interesting for me. So let's see for my next video tutorial.